more cozy meeting than normal, so thanks everybody for showing up on this kind of crappy rainy day. So first off, I want to give a little bit of credit to Uber offices like we always do. They host us for free every month, and they're wonderful. So if you are in need of office space, give them a holler. They're a good group. All right, Andy, you want to come up? Sure. All right. This is the man who paid for the food, the pizza, and the beer. Yeah.
Licensure. So I'm Andy Stevenson from Blue Canopy. We are a cybersecurity and secure app development company based in Boston, but a lot of our clients and folks are based here in DC. So obviously, web application security is a very important thing to us and our penetration testers. So enjoy the pizza and beer. Thanks for coming.
Quick question? Sure. Are you guys hiring?
Oh, we're hiring a lot.
All right. Please talk to Andy or Carrie in the back.
Yes. There you go. Awesome. Thanks.
Oh, good. PowerPoint is having issues. All right.
Of course, right.
So I'll continue to talk while PowerPoint is getting on issues. Cool. So if you need the restroom, they're on the hallway over by the elevators. The key is on a big, like, water bottle bundle with keychain thing, usually on the front desk. If you need the Wi-Fi, it's right there. And let's see. So anybody here, this is your first OWASP meeting, first time coming out?
That's the first.
That is the first.
What's the initiation?
We're going to give you pizza and beer. No. Usually we have like 10 people or 15 people to pick on, so thank you for coming. Oh, okay, we have another. You volunteer? Okay, I got you. So if you didn't already know, OWASP is it's a global 501c3 organization. We kind of dedicated to improving the state of software application security worldwide. There's a whole bunch of local chapters here, Baltimore, Northern Virginia, a bajillion across the United States and around the world. I think I saw one for like Riyadh open up like 3 or 4 months ago, and Hungary is very active, that sort of thing. So local chapters are really awesome. There's a lot of stuff going on, and no matter where you go, there's almost certainly any big city that's going to be an OWASP chapter, if not start one. Another thing that OWASP does is the projects. You go on OWASP.org, there's a whole bunch of resources, documentation, entire books, technologies. OWASP Zap is a proxy tool. We got OWASP WebGoat to do training, kind of train yourself on how to break into websites or train other people. There's a lot of really awesome resources out there for you to use if you want to get into the space or if you're already in the space. So they're awesome and get involved. Let's see. So as always, for meetings for us, for OWASP DC, we try to meet. We do meet on the first Wednesday of every month, except next month because there's DEF CON and most of the people are going to be gone. We're going to meet the second Wednesday next month, and after that is this is part of our regularly scheduled program.
I'm ready to shoot, Mike. You can stop now.
Okay, all right. Next month, right after DEF CON, we're going to have Shavinsky, I forgot his first name, Steve Shavinsky from CloudStrike to come in and talk, which should be really good. We're going to have somebody else set up for September, October, November. If you have any great ideas of things you want to talk about, reach out to me or Brian over here, and we'd love to hear you talk, because we're going to start looking for people to come up to the end of the year. December, we always have kind of a joint social thing, less of the lectures and more of the drinking with the OWASP Northern Virginia chapter. We'll be doing that out in Alexandria, Arlington usually, somewhere there. Yeah, kind of halfway in between. So with that, I'm going to pass it over to John, Mr. John Callahan, talking about his SQL Viking, right? Yep. SQL injection pen testing tool. So here we go. It's off to you. Was the TV once again turned off?
I would say.
There we go. I think that's the right one. Yeah. Okay.
Cool. How's it going, guys?
Good.
Excellent.
Awesome. Your enthusiasm is duly noted. What's this? Connects, maybe.
Are we going to do technical difficulty?
It's thinking about it.
Keep talking. Should I keep talking?
Hey.
All right.
No, please. Fantastic. Cool. All right, so today I'm going to be talking about a tool called SQL Viking, which is something I've been developing kind of just on the back burner for a couple months now. A little bit about myself first. I am a AppSec analyst, currently working for Visium. Cut my teeth working at the DoD, cutting away at .NET apps for the most part, .NET and SQL servers, so that's really where most of my experience is. Although I do have an inherent love for Python, and that's what SQL Viking is written in. So what's a SQL Viking? I'm sure you're all wondering what that is. SQL Viking is a post-exploitation tool that focuses on exploiting plain text or unencrypted connections between application servers and database servers, or really database servers and any client at all. With the mindset of why clone the database when all the information you'd ever want is already flying over the network free to grab. This is disturbingly common in production spaces. I reached out to a lot of people I know who work as developers or in the IT sphere. I came across one person who said they had encrypted database connections. With the assumption, a lot of the excuse being that there shouldn't be attackers on our network anyway, which is a great mindset to have, especially considering that your application servers are your forward-facing. It's usually the first thing somebody hits. Someone pops your application server, they're on your server, now they can see all your database traffic. Your sensitive application, all that sensitive data is now yours to grab. So the inspiration for this, you can just see a PCAP here. I was working on something one day, had Wireshark opened, noticed this database traffic in plain text, select version, select added version, just sitting there in my PCAP. And I was just blown away. I don't know why I never really thought about it, but I was just really surprised that this kind of stuff isn't encrypted by default.
Is this like an agency or what type of organization was this?
It was in a test environment. It was a test
Which
environment.
defense agency?
A three-letter one.
Were you doing like a man-in-the-middle tech here, or?
No, I was not man in the middle. This was just packet capture. I was a third party listening to traffic going back and forth between an application server and a database server. And I happened to be on the subnet between the two. So I could see the traffic going back and forth. And then the response here, added version, is Ubuntu. And then I believe the version number is encoded somehow because it doesn't just show up in the packet itself.
Is the subnet secure or?
Again, it was a test environment, so not really. So the structure, Python 2.7. I know Python 3 is better, but I leveraged Scapy for the packet capture piece, and it has yet to be successfully ported to Python 3. So right now I'm stuck on 2.7 until I either pick a different library to use or Scapy does get ported. But the idea is it's kind of broken up into two pieces called one scout and one pillage. They work very differently and they're named so, and I'll dig into really why they have those names and what they do in a second. But I built it with extensibility in mind. Right now it has a lot of support for MySQL, a little bit for SQL Server, but adding support for other databases is really simple. There is a base DB class. You just extend a couple of methods so you can parse the actual traffic, and then you return the data back to the main parsing client. And then that'll handle all the logging and storing for you, so you don't actually have to touch the meat of the app. You just have to be able to handle the parsing of the data. So using SQL Viking, very easy, just pointing to a config file. So since this is a post-exploitation tool, just as a general rule of thumb, when you're pen testing or breaking into a system, one of the first things you do is enumerate a network. So when I first written it, I wrote it to be able to fingerprint databases as it just pulls everything it can off the wire and tries to fingerprint and say, oh, this is SQL Server traffic, or oh, this is MySQL traffic. And realize that was kind of overkill because you as an attacker probably already know that this server over here is MySQL and this server over here is SQL Server. So you can just point it at it and only listen to those boxes. You can preload queries to run via pillage, which I'll explain what that means in a second, and specify how to handle all your data logging. One of the things I want to be able to do is that you can put it on a network and fire and forget it, and set it to just like dump all the data it's captured in the last 60 minutes to some endpoint somewhere. That way you as an attacker can just set it up and then walk away, and you'll just get a constant data feed out of it. And then there's also a runtime menu, which is pretty hacked together. Obviously, I won't get into why. But most of this functionality can be modified at runtime. Big piece really being pillage. Quick shot of the big file, your typical layout. So here's a shot of the menu. The big things to be aware of are the, can you guys even read this?
Yeah.
Yep, awesome. This one better than last time. So the top 3 lines, current number of known databases. So those are the number of databases it's actively tracking on. IP and port number. Number of known connections. So SQL Viking tracks by TCP connections between a client and the database server and actively watches all that traffic going back and forth and maintains state in the process. So those are the number of, there's currently in this screenshot, there are 2 connections to the 1 database server I'm tracking on right now. And then the current number of queries captured, exactly what it sounds like. I pulled 16 queries so far. A couple of the menu items, you can dump everything on command to an out file wherever you want it. Add a new database to track on, so if you're going through your enumeration, you happen to spot another one, you can just quickly add it in there, you don't have to restart or anything. And then run a query against a specified database. Again, that's the pillage piece, we'll get into that. So, first off, Scout. Yes, that is a Viking riding a unicorn with an AK, sneakers, and riding a rainbow in space.
Because why not?
Yes, I Googled Viking and got this and was ecstatic. And then framed my talk around this, obviously. So Scout. The whole idea of Scout is really the boring piece in my opinion. All it does is it sits there and gets fed all the traffic that Scappy's pulling off, goes through and parses it and says, oh, this is a select query against this table, here are the results, and correlates all that together for you. It'll also store credentials during the handshake, such as the username and the password hash and the salt. I haven't implemented that functionality yet, but that's on my to-do list. The idea being that if
The salt is on your, or all that?
no, so when you actually log, well, for MySQL and SQL Server, you log in with the hash version of the password, not a plain text copy. So you can pull that hash directly off if the connection's not encrypted at all.
Right.
So you can pull that hash off, pull the salt off, and then take it offline and start attacking it. And if it's weak, there you go. You got the creds. You're good to go. You don't have to do anything else. You've got a legitimate account on that database. Correlates all the queries with the results. So instead of just dumping everything in one mass file, it correlates this query with this result. And again, this becomes more important on much more busy networks where you have like a couple hundred open TCP, well, not a couple hundred, maybe a couple dozen open TCP connections between the server and the database. That way you're not getting like, so you have 2 queries getting fired off simultaneously, but the results come back in different orders. So you're getting miscorrelations between queries and results. So it'll track all that and correlate it all for you. Oh, and one thing I also want to do is build out the database schema. Again, that's on my to-do list. So it'll say like, oh, this database has these tables inside of it and these columns. So then using tag can come back and say, oh, hey, this looks like an interesting piece to pull some information out of. That's a social security number column. I'd like that. So demo time. I made a video because I pissed off the demo guys way too many times. So Scout, here we go. Now can you read that?
Yeah,
Didn't think so.
really hard.
Okay. Feel free to get in close. It won't bother me at all.
Also, the slide deck and the crowdcast we're going to be putting up online after the meeting. So this stuff should be visible in a number of hours.
Okay. Well, I know you can't really see it, but I'll still explain what's going on. So on the left side, we have SQL Viking that's currently running. I preloaded it with my target database, which is on the right-hand side. The right-hand side is just a MySQL client connecting up to a test database I have set up right now. Okay, cool. So you can see, well, you can't see, but I logged in. It knows there is one open connection right now. It's pulled 2 queries off the network. Those 2 queries being the 2 it used to log in. Or do the actual handshake. So I'm actively tracking on this connection. On the right-hand side, I'm just going to run a use testdb command, which will switch my schema over to test. Yes.
So the right-hand side is tracking the left-hand side? Is that?
The left-hand side is tracking the right-hand side. So the left-hand side is SQL Viking, and the right-hand side is the command line interface for MySQL. Yeah. So I'm actually actively running commands on the right-hand side, such as use testdb, use MySQL, select that version. And on the left-hand side, you can see the queries number. just continuing to jump up as it's pulling all this traffic
So
off.
it's just reporting on the number of queries, the number of hits.
Yep, for right now, yeah. But I was gonna write it to an outfill really quick.
It's not just reporting, it's saving.
Yes,
But I
yes,
mean,
it's
that's
actively
really
tracking,
important.
yeah, and saving. And then I wrote it to a file here.
So you're using just a file output for storage?
Well, actually, it's all stored in memory,
You
which I
want to
use
use
to
an
fix.
encrypted database connection as your
It's not my data.
ultimate nightmare.
Yeah, right. Right now, all for out files, all it supports is just human readable. I do want to implement JSON and CSV so you can pipe it into some other consumption script you may write or what have you. For the time being, it just pipes out in this really ugly but kind of human readable format. At the top, you can. So at the top, you have the database type, MySQL, the IP and the port number, and when it dumps all the output, it correlates all to that one particular database. Credentials at the very top, it's all the root account get logged into it. The other three pieces are the hash assault and the authentication scheme that gets used. And then you scroll through, you can see all these queries are getting run. Right there is the actual handshake. You can see the root account is being used, the salt or the hash is in there, and the MySQL native password is the authentication scheme used. Show databases, information schema, MySQL, performance schema, test DB. Show tables, all the tables that are in test DB. There are still a couple of errors. You can see protocol error, expecting EOF. That request customer login is actually a request for all the columns and the column data, or not the column data, but the what kind of columns they are for that table, and I'm not able to parse that out yet. More show tables and more failed column parsing. And then you can see the select star from testdb.customer login and the select data version is 5.5.4 Ubuntu. And then the select star from testdb.customer login, you can see all at the very top, the first line will be the columns for that table. And then everything, or the columns for that result set, I should say. And then the rest is all of the rows in that table, including the base64 password in column 3. Yeah, fantastic, right? So once I scroll down here, you'll see this is actually a pretty large result set. SQL Viking is able to handle fragged packets, which comes into use later. So even if you're running these massive queries and it gets split over 100 packets, it'll still be able to glue them all back together and parse everything for you, which is nice. So that's Scout. Any questions so far before we get into the fun stuff?
Do you just have a UI right now, or is it also like command line?
It's command line. So all that stuff you can do in the UI, you can just feed into your config file and it'll just run. Again, I don't have support for the automated dumping of information. So right now it just stores it all in memory, doesn't do anything with it yet. But that's another goal, another thing to be able to do. So any other questions?
Which database is it supporting again?
MySQL a lot, SQL Server a little bit.
Okay.
Yeah,
I'm just curious, so on a switch network where the traffic's only destined to a single port. And
this will not work. This will not work.
Okay, yeah.
So,
Okay.
Yeah.
So if you have an Armcache poisoning attack or something, where all the traffic is going through your computer.
Or if you own the database or the application
Sure,
server
right.
itself, so if you're actually seeing on one of the boxes, you'll be able to see it.
Alright.
Yeah. So it does have very limited uses, but it is very powerful in what it can do
Sure.
if you're not properly protected. In my opinion, the real power comes with pillage, my other awesome Viking picture. Because we're pillaging databases, man. Not nice people. So pillage works off a technique called TCP injection. This is, as opposed to Scout, which is very passive and basically invisible unless you happen to see the actual SQL Viking script running on a box. You'll never find it. Pillage, on the other, is the exact opposite end of the spectrum. The second you launch it, you're going to set off every IDS alarm on a network. However, it is extremely powerful. You can do a lot of cool stuff with it. And how this affects web servers and other clients varies vary greatly in terms of how much damage you're actually going to do, or in terms of how much visibility you're going to cause from a user perspective, usability perspective. So quick interview of what TCP injection is. First, TCP. I'm sure you're all aware. A couple of flags you need to be aware of: your SYN, ACK, push, and FIN. So your SYN, ACK is your typical TCP handshake you use to establish a connection between your client and server. After that, all your data gets sent back and forth. Then when it's done, you have your FIN, ACK, and then the connection closes. Additionally, with TCP, you also have sequence and acknowledgement numbers. These are used to track exactly what they sound like, track the sequence of packets. So on the internet, when you're sending packets over, you may send packets 1 through 5 in the order 1 through 5, but they may reach the destination in order 3, 4, 2, 1. So if the client tries to, or the server tries to glue them all together in the order it gets it, it's not going to turn out correctly. So these sequence and acknowledgement numbers are used to put packets back together in the correct order and make sure you received every packet you're supposed to get, so you don't have 1, 2, 4, and you're missing 3, don't even realize it, try to parse the data, then have errors. So because of this, because of what it's supposed to be used for, sequence and acknowledgement numbers are 100% predictable. They're supposed to be. However, we can abuse that via this slide that I just talked about. So what happens if we put a packet on the wire with a spoofed MAC and IP address with a valid sequence and acknowledgement number? We get TCP injection. So how this works is, so you have, and excuse my crappy MS Paint art, I'm not an artist by any means. So you have your client and database server talking back and forth, and connections already established. Your client sends a packet to the server with sequence number 30 and acknowledgement number 90 and a length of 100. The database server receives this packet and sends the next packet back with an acknowledgement number set to the sequence number of the previous packet. So the client sets sequence number 30, database server sets acknowledgement number 30, saying, yes, I received this packet, we're good to go. In the process, the database server also sends other data along with it with a sequence number of 110 and a length of 40. Knowing this, if I wanted to act like the client and send a new request to the database server, I know that the next sequence number is going to be 130 because it's equal to the previous sequence number plus the length of the previous packet. Previous sequence number is 30, previous length of the length of the previous packet was 100, next sequence number is 130. So I put this directly on the network, I spoof the IP and MAC to make it look like it comes from the client, hits the database server thinks it got another request from the client, parses the data and shoots out the response. The response goes to the client, doesn't go to me, but because I'm already on the network actively watching all this traffic ping back and forth, I just have to pull it right off. And I effectively just ran a command on the database without knowing the credentials at all. That's freaking cool in my opinion. Granted, you just really messed up both the client and the database because now they're all off. The client is 1 packet behind and the database is 1 packet ahead. And this is where things get really weird in terms of how it gets handled. I've tested this against a couple of stacks. I don't remember what version it was, but .NET and SQL Server handled it. One version of .NET and SQL Server handled it very gracefully. From a user perspective, you couldn't even tell something happened. It realized there was an error, it gracefully closed the connection, reestablished, and you were good to go. It was completely invisible from a user perspective. On the other end of the spectrum, I've also seen the entire application just crashes. And you've got to hard boot it, which is not good. That's a great way to throw up a red flag that says, hey, I'm on your network probably doing things I shouldn't be doing. And it goes everywhere in between. And I've also had yellow screens of death from .NET. You'll see when I run the demo against the MySQL command line client, what ends up happening is the client sends out a packet saying, I didn't request this. And then the database responds and resends the packet. It says, I didn't request this, and then resends the packet. And they ping back and forth. In a matter of like 3 seconds, they send like 3,000 packets. It's ridiculous. They just keep pinging back and forth until you control C out of the client. Does not handle it gracefully at all. So, quick demo of that. So I know this is hard to read, but I'll explain what's going on as we're walking through it. So same setup as before. Left-hand side, we have SQL Viking. On the right-hand side, we have the database client. So on the left-hand side, I'm just going to tell SQL Viking, hey, run this query when you get a chance. Specifically, select star from testdb.employees limit 1. So we're going to pull the first row out of the employees table. Tell it the IP import to execute against, quick confirmation, good to go. Then on the client, we're going to run a query or two. And I'll explain in a second why you have to do that and why it doesn't just shoot it off immediately. But after you send that second select out version, on the left-hand side, you can see sent 1 packets. So that's just a response from Scapy saying, hey, we put a packet on the network. And then we go on right to the out file. And really quick, this is what I was explaining before. Packet numbers on the side are 4,400. And you just scroll, keep scrolling, 5,400, 58, almost 6,000. So 1,400 packets in 2-3 seconds. Same out file again. You can see the 2 select edit version commands that are run, and then my command select edit or select testdb employees limit 1. The command is parsed by the database, and the response was put out. You can see it's got my information in there: Callahan John, John Callahan, certified application security specialist. And it actually comes back a couple of times, and that's because the client is saying, I didn't send this, and the database server says, here, have it again. And it just keeps feeding back and forth. On the right-hand side, I can try to run a select edit version again, and the client just hangs. It doesn't do anything until you Control-C a bunch of time, kills the query, kills the process, and eventually just exits out and kills the connection entirely. And then you actually have to re-authenticate and get back in. Cool. Cool.
So when the .NET SQL Server smoothly accepted, are you able to do multiple queries? Are you able to continue this chain going, or is this like a one-shot and you get whatever you want?
So you would actually be more likely to do that if you crash the server entirely, because what ends up happening is there's a race condition between. So there's a race condition between when I put my packet sent to the database and the client sends its next packet to the database. And that's exactly why I wait for a database response. Otherwise, if I try and inject it between the client request and the database response, you have a really tight window between the database processing the request and sending its response out. Whereas there's a greater likelihood that the client send out a request, it's done, and it's doing a bunch of different processing on its end before it sends another request out to the database. But yeah.
Well, I'm curious, what happens under the hood when you do a parameterized query? I guess you sound like the prepared statement.
So if you actually look at the network traffic, it looks almost exactly like it would look in text or in a programming language. So you actually see the select star from users where username equals @user, and then you'll see a bunch of jump data, and then @user equals, and then whatever your value is. So you could send a spoof parameterized query, but it's not really going to help you at all. I mean, it's just going to cost extra resources to try and generate a valid query to send to the database, whereas just a raw query is very easy to generate. To answer your question a little bit more, Mike. So if this in the process managed to, so let's say in the MySQL command line piece, when it's just pinging back and forth, the DBA or whoever kills out his connection, and I'm watching that. Oh, actually, no, that wouldn't work. Never mind. A fin gets sent out, so the client's going to close the connection, or the server's going to close the connection, and that's so unless you can like flood the network and keep that fin packet, that initial fin packet from getting sent out, you're really not going to be able to get more than one. You're going to have to wait until another valid connection is established, and then sync that one to get your query run.
So essentially, the privilege you've got, it's like a really big Derringer or something like that. So you got one really good shot, you can do it, and then you have to wait for another connection.
Yeah.
To be established.
Yeah.
So really what you want to do is add a user.
Yep, exactly. You got one shot, so you better make it count. Something that gets you elevated access, or if you already have an account or like legitimate credentials and you know this person's an admin, you can leverage them to elevate your account to get more rights. So whatever it is, it needs to be very useful to you. Don't just dump the schema. I mean, you can pull that off anyway.
But essentially, you've got a credential-less free query against the database to do
exactly
that connection already has access to do. So.
And if a SQL Server and a root account, and or an SA account,
Which
you could execute command shell.
Which you should never see in production. I'm sure you never do, right? Nobody's here never seen that.
It's like our database connections are always encrypted.
Which is why you should never, ever, ever use the stick. That's for that.
Yep.
I'm done now.
You seem scarred, Mike.
Yeah, a little bit.
So yeah, you can do a lot with one query, but you better make it count. Don't fat finger it, because that would suck. Triple check that what you're executing is really what you want to do. So any questions, by the way, on that stuff before I move on to more cool things you can do with Village? All right. So again, I spent most of my time implementing this against MySQL, specifically because I have more experience with SQL Server, but the network protocol is infuriatingly dumb. Microsoft wrote the standard and then implemented it differently, which is very annoying. So you get like 90% of what you need, and then have to reverse engineer the other 10%. MySQL, on the other hand, is very simple protocol, very easy to tear apart. But MySQL has a couple different authentication schemes. So when the initial client reaches out to the server and does a client hello, the server will respond with a bunch of different information like use SSL, use this authentication scheme, blah, 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 all these settings you can set. One of them is typically what you use is the MySQL native password. That's the modern authentication scheme. But prior to 4.1, I want to say, they used MySQL old password, which is very, 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 very broken. Unfortunately, I have yet to find any technical write-ups on how to actually exploit this. But if you just do a quick Google search on MySQL old password, you find a million different forum topics that say don't use this. However, most clients still support it for legacy support, I guess. So what you can do is you can leverage pillage to tell your client to connect via this MySQL old password authentication scheme. So what you do, or in a typical handshake, client reaches out to server, client hello, server responds with some information, including authentication scheme, client parses it, generates its authentication packet, and sends it off to the server to verify. So in this scenario, I'm sitting and I'm watching, I know this is a MySQL database, and I see that initial client hello packet come out, and then before the server can respond, I put out my own server hello packet with the authentication scheme set to MySQL old password. The client sees this, says, okay, I'll authenticate using this scheme, takes this password, hashes it extremely weakly in whatever horrible manner that is, and then sends it to the server. Obviously, authentication is going to fail because the server didn't request it in that format. But again, I, as the attacker, just pull that off the wire. Now I have the password. I can crack it offline, and I have a legitimate account. I haven't actually implemented this yet. Well, actually, I did implement it and test it, and I lost my code. I don't know how I managed to do that in 2015, but I lost a piece of code. But it actually handles fine from my SQL client perspective. I don't know how it would work from like an ODBC layer, but CLI, it just said authentication failed and kicked back, and then you just retype your password, you're good to go. So as far as a DBA thing, so you just fat fingered his password and you just silently stole it. Oh, and a quick back in here. Oh. Speak handshake, and then the server sends out its server hello, server greeting. And then at the bottom here, you can see it says MySQL native password. So the very bottom is where the authentication scheme is specified. And then in the response, you get root, the password hash, the password salt, and MySQL native password again. Telling the server like this is what I used. Also, quick shout out to Backronym if you guys have heard of that attack. It came out like 2 months ago, maybe. Basically, you can man in the middle of MySQL connection, and there's a flag that said use SSL, and you can just flip the bit, and it wouldn't use SSL. Even if the server says, I need you to use SSL, and you flip it, and the connection comes back and doesn't use it, and it's like, okay, we're good to go. It's the little things like that that make you laugh. So the fix, encrypt everything. Unless you have some really intense database queries getting run, or you're running on some archaic hardware, there really shouldn't be that much of a performance overhead to encrypt your connections. That said, you use TLS to encrypt your database traffic, so all the rules apply for when implementing TLS on an application server from a client to app server level as well. You need to make sure you're using 1.2, use Diffie-Hellman key exchanges, don't use RC4, don't use SSL3. You can also do client verification as well instead of just server, since you know these 3 application servers and these 2 DBAs are the only people who should be connecting to this database server. So you don't really have a key distribution problem. That's not an issue because there's only 5 people who should be connecting anyway, as opposed to the general public. So yeah, encrypt everything. Future improvements, fingerprinting. Again, I talked about this a little bit earlier. It's a pretty cool feature, kind of superfluous, but could be useful if there's a database server running on some really random port somewhere that you would never think to look at. Encryption support. So even if you encrypt your databases, if I manage to steal your private keys, that doesn't really matter because now I can just decrypt everything. So what I want to be able to do is to be able to feed in the private keys that you stole to SQL Viking and say these are correlated with this client and this server, and then it'll just function as normal. It'll decrypt everything on the fly and store it for you. And of course, more databases supported. I've got 2 out of how many databases exist? A couple hundred, maybe. And again, I built it with extensibility. Right now, it's not very clear on how to do that. That is, again, on my short-term to-do list, is to kind of make it more clear as to how to implement support for new databases. It's not, I didn't comment on it at all.
Question.
Yeah.
Is this a solo project? I mean,
Yeah, it's just something I wrote on the side for fun. So for those of you out here who do code and do know Python, please don't judge me for how crappy this code is. This very much started as I wonder if I could do this, and then wrote a little chunk of code. I was like, oh, I wonder if I could do that, and just kind of like ad hoc'd it together. So it turned out as like this Frankenstein monstrosity that was really ugly. I went back and cleaned it up a bit, but it's still not clean code by any means. So please fix it if you feel so nice. And then repo, repository, Atticus, 2 T's, 2 S's, / SQL Viking. Any questions? What's on it?
Are there any implications, particularly on the SQL Server side, if there is mixed mode versus SQL authentication? Does that impact?
I would imagine not. It would impact the handshake, and I actually haven't messed around to see what mixed mode authentication looks like when it's actually getting passed back and forth. I would assume it's actually vulnerable to a pass the hash vulnerability on Microsoft. But again, I haven't looked, so I can't really comment on that at all. Yeah. Anyone else? Cool. Quick 2-second plug too for another project I'm working on because I have ODD when it comes to baking things. If any of you have ever done password cracking before, OCL Hashcat is pretty much the de facto tool. Best of breed right now. If you want to do a distributed hacking, there's no official support. So there's a tool called Hashtopus, which sucks. And I was going to fix it, but it's written in PHP, and I vehemently hate PHP. So I'm running my own. Sorry, Curly Boy. He's the author of Hashtopus. There's no name for it. There's no repo for it, but I'm sure it'll get pushed up at some point. Right now, I just have a command line proof of concept. But again, it's going to be another Python implementation, probably on top of Django. So yeah, that's it.
So thank you again to John. We do still have 3 dozen pizzas left. Please help Cherry and Andy eat as much as you can before you leave. There's some beer as well. So thank you everyone for coming out, and see you guys next month.
all right.